All right, we are back, and we're about to learn about some new concurrent lines. And these concurrent lines are called altitudes. Now, be careful, they're altitudes, not altitudes. That's a board slapper, isn't it? Get it? Altitudes. Oh man, that joke just made my day. I hope it made your day too. Oh, hey, Babette, my cat's meowing. But anyways, apparently my cat wants to join in because she likes altitudes too. But anyways, so you're probably wondering, what is an altitude? So an altitude is a concurrent line that starts from the vertex of a triangle and extends to the opposite side of the triangle and is perpendicular to the opposite side of the triangle. Now, first of all, we've talked about several concurrent lines, which pretty much all of them have to start from a vertex and extend to the other side of a triangle. The only one we've talked about that does not have to do that is a perpendicular bisector. The angle bisectors start from a vertex and extend to the other side. Also, we've talked about medians, which start from a vertex point and also extend to the other side. So altitudes also start from a vertex point, but when they hit the opposite side, they must be perpendicular. So, what does it mean to be perpendicular? Now, do I mean perpendicular or perpendicular? I just got board slappers left and right. But anyways, what does it mean to be perpendicular? It does mean to intersect the other side at a 90-degree angle. Okay, so these segments, altitudes, start from a vertex point and extend to the other side. And when they do, they slice through the other side at a 90-degree angle. Neato, right? Well, let's keep talking about these altitudes. So there's an awesome point where all three altitudes come together. So these are concurrent lines because they all intersect. There's three or more lines that intersect. Okay, and they're going to intersect at the point of concurrency, which in this case is the orthocenter. Okay, so we're going to have three altitudes. This one starts from the vertex point and extends down, and bam, it hits the other side at 90 degrees. Bam. This one starts at this vertex point, extends down, and bam, hits the other side at 90 degrees. Same with this one. This altitude is going to start from this vertex point, extend to the other side, and bam, hit it at a 90-degree angle. Cool beans, right? And where all three of these concurrent lines come together is our point of concurrency called the orthocenter. Try saying that 5 times fast. Orthocenter, 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 orthocenter. Harder than it seems. Harder than it seems, you guys. So be careful with that one. It's a tongue twister. All right, now we're going to learn some nifty things about the location of the orthocenter, different types of triangles. Okay, so in an acute triangle, where do all three of these altitudes come together? Are they on the inside of the triangle, outside the triangle, or on the triangle? They are inside of a triangle. So in an acute triangle, when all three altitudes come together, the point of concurrency, which is the orthocenter, is inside of the triangle. Cool beans, right? I know, I agree. I always agree with you guys. We're so much alike. We're pretty much besties. But anyways, so an obtuse triangle is a little different. We're going to have some altitudes that are on the inside of the triangle and some that are on the outside. So this first one's pretty straightforward. It's going to start from the vertex, and when it extends over, bam, it's going to hit it at a 90-degree angle. Now you're probably like, Miss Long, why does the line keep going? Like, why do you need to do that? That's pretty unnecessary. Well, there's a reason, and I'm going to explain why I kept extending the line momentarily. Now this side, you're probably like, Miss Long, it seems like no matter where I draw this line, I cannot hit the other side at 90 degrees. Well, guess what, you guys? You're not going to be able to because this is an obtuse triangle. So what I'm going to do, I'm going to be extending this side of the triangle so somehow I can draw an altitude and hit the extended side of the triangle at a 90-degree angle. So this is technically where my altitude will extend to. Okay, and when I extend this side of the triangle, guess what, you guys? Now it can hypothetically hit that side of a triangle at 90 degrees. Isn't that sneaky? I just snuck attack you, didn't I? All right, the same thing's going to happen with the third altitude. So I'm going to start from this vertex point. Now, if you see again, no matter where I draw my hypothetical segment, I'm never going to hit it at a 90-degree angle. It's just not going to happen. Okay, so I'm going to extend this side of the triangle so that this side could hit the hypothetical side at a 90-degree angle. Okay, so this is where my altitude is going to be. And when I extend this side of the triangle, do you guys see it? Do you see it? Let's zoom in. Do you see it? Do you see it? Do you see how now it's more of a 90-degree angle? Look at that. So now I have 3 altitudes, but in order to do this, we had to extend the sides of the triangle, which means the orthocenter is going to be located outside the triangle. Wasn't that pretty cool? Awesome sauce. I agree. I agree. Like normal. So bam, that's where our orthocenter is. All right, now in a right triangle, this is pretty interesting. So again, our first one's pretty straightforward. I'm going to extend this segment from the vertex and bam, it hits it at 90 degrees. Now in a right triangle, what is one of the angles? Oh man, you guys are too cool for school. You just know everything. I don't know why I make these videos, because you guys know everything. I better hurry up, because my Mac's about to die. Let's see if I can rush it. I've got a little bit of time, so I think we're okay. But anyways, so there is a right angle that's already in a right triangle. So when I start from this vertex point, when I extend it to the other side, what angle is already created? It is a 90-degree angle. Again, you guys are super smart. You're like Albert Einstein. You're so smart. But anyway, so this one hits the other side, and it's already a 90-degree angle. Same with this one. This segment right here is going to start from the vertex, and when it hits the other side, there's already a 90-degree angle there. Holy hot dog, right? I know. Okay, so on this one, the point of concurrency is actually right here on the triangle, because that is where our 3 altitudes come together. So in a right triangle, the orthocenter is located on the triangle. Did that just blow your mind? It just blew my mind. That is like the coolest thing I've heard all day today. Whoa. Insane. So the orthocenter is on the triangle. Whoa. All right, so we're going to be applying these concepts of altitudes where segments start from a vertex and extend to the other side and hit a 90-degree angle. So these 90-degree angles inside of the triangle just might help us solve for other angles inside of the triangle. So you guys get ready, get excited, because example 1 from altitudes, not altitudes, but altitudes is going to be a blast. So you guys get ready for example 1. You can pause the video and watch example 1. And guess what? That's it, you guys. That's all, folks.